start today, we're going to just recap a few things that we've covered and then we're going to push on. So on the diagram, I've got a stem and leaf. In fact, I've got two stem and leaf diagrams based around a single stem, a leaf to the right and a leaf to the left. That allows you to compare the two more easily. And I want you to think about all these words around it and think about what they mean and calculate them if possible. So pause the video, maybe spend 5 to 10 minutes on this. Do your best with it. Okay, I'm not going to go through all of this, but I'm going to give a little summary of my answers. We can find the highest and the lowest values very quickly. We can find the mean quite easily by adding the values up and dividing by how many there are. We can work out the mode by looking for the most common, 22, because I've got 3 lots of 2's here, and 15 for brand B. And then don't forget we can find the median by looking halfway through, and I put lines to indicate the halfway through point. We need to be careful because the stem and leaf diagram on the left, we're actually reading from right to left. So actually the 9th value is 19 and the 10th value is 21. So we look in between that to give us the median of, actually that should be 20, I've just realized. No, that's the mean. Sorry, there's nothing wrong with what I did. Where has it gone? Here it is, 20. And then there's a line through the middle value for brand B, 22. So hopefully that's all good. And then for the interquartile range, don't forget we kind of split it in half and then look for the lower quartile and the upper quartile, which I've indicated in green. I'm not going to talk about that in any more detail. Just to talk about the rest, the key is this thing here. Let me try that again. Okay, that tells us what the numbers represent. This is discrete data because it's single values. We hopefully understand what that means. And continuous is when it can take any value. Raw data, we have raw data here. We lose that when we write it as a frequency, a grouped frequency table, for example. Okay, that would be group data. We can get unordered and ordered stem and leaf. And they give a distribution. We'll be looking at other distributions. And this is an example of quantitative data. Quantity, numerical, as opposed to qualitative, which is when you have things like eye color, for example. So I'm hoping that you're looking at this and you're happy at finding all of these quantities and you understand what all these words mean. Because why have I started with this? Well, I just want to recap then what we can find. I've not covered variance here. I didn't ask you to find the variance of the stem leaf, but you could have done. But we can now, if we have a list of data, and I think I've called this discrete data sometimes in the past, and I shouldn't have. It's a list of data, then we can calculate measures of location, and we can calculate measures of spread, and they've got different pros and cons and ease of finding them. What else have we done? I just want to recap. We've looked at frequency tables, normal ones and grouped ones, and we've looked at how to find the mean, the mode, the range, and the variance of these things. What we've not looked at is the median and interquartile range. We'll come back to that. If we look at cumulative frequency, here's an example of a cumulative frequency. You can find the median by looking halfway through the data. So I'm only basically recapping this very quickly, but we can look at the 30th point, which is halfway through 60. For this data, we don't look at we don't add 1 to the 60 and then divide by 2 like I've been talking about before. We just go straight for it basically because it's kind of continuous data now. So you just divide the 60 by 2. We can read off, and we can also do similar to find the lower quartile. Okay, at the 15th frequency point, and 45 will give us the upper quartile. So we can find the interquartile range on cumulative frequency graphs. That was very quick. We can obviously also find the range. It's not possible, well, no, I say it's not possible, that's not right. It's challenging to find the mean, mode, and variance from a cumulative frequency. You can make estimates because you can turn this back into a frequency table. I suppose it's just a bit of hard work, but you would have the frequency table to start with for your cumulative frequency diagram. So you're more likely to work out the things that I've put crosses by, you could work them out from your frequency table that you start with. Similarly, you could do the same for histograms, because if you've got your histogram, you can get back to the frequency table. We've got a group from 0 to 5, we've got a group from 5 to 20, so that gives you your groupings here. And then if you find the area, if you do 5 times 7, 35, that will give you a frequency for that group. So it's possible, again, to revert back to the frequency table for the histogram and hence find all of these things here. We'll come back to the median and interquartile range. Finally, we've looked at, I haven't got an example of one here actually, but we've looked at box and whisker plots. They give a 5-number summary, so they tell you about the median, the range, and the interquartile range, but in this case, these crosses are definitely crosses. We go put 2 crosses because we lose the actual raw data, we can't get back to it, okay, and we're not able to find them. For this, I probably, in hindsight, should put smiley faces because we can get back to the frequency table, but it's very, very easy to find the median, range, and interquartile range here. Okay, that was just a little summary. And why have I given this summary? Because there's these blanks that are left. How do we work out the median for frequency tables and histograms? How do we work out the interquartile range for frequency tables and histograms? And that's what we're going to look at today. And we're going to look at it in detail because you might have covered it before, like the basic way of doing it, saying which, for example, you should have looked at working out. I'm going to talk about it now, just a brief version. You should have looked at what group the median would be in for this frequency table. Because if we add the frequencies up, 2 plus 5 plus 7 plus 12 plus 10 plus 4, we get 40. Okay, the median position is going to be 40 plus 1 over 2, which is 20.5. And then we can basically we can add up and find out which one it's in. So we've got 7, 14, it's going to be in this one. So previously, you should have studied how to work out the group that the median is in. And in this case, it's here. But interquartile range is going to be, a lot trickier. And in this lesson, we are therefore going to look at this in more detail. And by the end, we'll be like this, and it'll be like this, because we'll have a much better method. We're not just going to find the group that it's in, we're going to find an estimate for the actual value. And the way we do this is interpolation. Here is my attempt at drawing a map of a tropical island. And we've got 2 weather stations on this island, one at A, where it's 27 degrees Celsius, and one at E, where it's 29 degrees Celsius. And my question is, how can we estimate the temperature at C, B, and D, where we don't have weather stations? Okay, I'm going to talk through this. Well, C, you might have noticed, is exactly halfway between A and D, so a natural thing to do is to write down 28 degrees Celsius. That's what I would go with. Of course, we don't have full information of the island. We don't know if it's a mountainous region somewhere. Maybe C is actually on top of a mountain, and that would take things into account. It would be a bit colder then, but we can only use the information that we have. Now, another way we might have got the answer to C is as follows, because this is going to link into B and D. It's to use the fact that it's going to be, it's 27 at A, and then if I look at this diagram, I see that there's an increase by 2 degrees as I go to the right. So, plus 2 degrees Celsius. So I can say, right, well, to get to E, of course, I do 27 plus 2. But if I look at C, well, it's going to be a fraction of an increase of 2. And that fraction is going to be the distance that I go along to C divided by the total distance multiplied by this full increase. And that gives us the 28 degrees Celsius. And you might think that's an overly complicated way of doing it, but it's going to really come into its own for B and D. Because if we look at B now, we're now going to use this method. It's going to be 27 degrees plus the fractional increase that is taking place. And now I'm going along 2, the full distance was 10, and I'm going to multiply by that increase in temperature. Okay, I'm just going to say this again. We know that over the full distance we're increasing by 2, so I'm just finding the fraction that I'm expecting it to increase by as I go from left to right. And we can work this out. I'm not, to be honest, not really interested what the answer is, but it's going to, let's do it. It's going to be, that's going to be 0.4, so we can estimate the temperature at 27.4 degrees Celsius. If you're with me now, if you're like, okay, you wouldn't have known B and D at the start, pause the video, have a go to find what the answer to D would be. Well, in this case, it's going to be very similar. We're going to be 27, and this time we're going 9 of the 10 kilometers. So my fractional increase in temperature, I can assume, is also going to be 9/10 of the 2 degrees Celsius, and that's going to be 1.8, so I'm going to get 28.8 degrees Celsius. And the point is, I could do this now, and maybe I should have asked this as a question, if instead I come up with some new coordinate f, where the distance is x kilometers, what would the temperature be? And so at f, it would be 27 plus my fraction, which is now x over 10 times 2, which of course will depend on x. And I'm going to get, actually, what's going to be happening, I've got my temperature at A, which is 0 kilometers away from A. I've got my temperature at E, which is 10 kilometers away. So I'm basically measuring the distance from A along here. I've got the temperature here, which I'll use a little t for. And what I've actually done is I've essentially fitted a straight line to this data. I've assumed that there is a linear increase going from A to E, and then I've actually just worked out the fraction that I've gone along the line. So in the case of D, it would be here, and I've worked out what I expect the temperature to be. If I'm going 9 along, I can calculate that this is going to be 28.8. So this is actually an example of linear interpolation, and I think the diagram brings it together. We are interpolating because you would have studied this before with scatter graphs. When you interpolate, you draw a line of best fit typically, and then you find out what would happen if you looked at a different point in between the values. It's in between the values. That's what interpolation means. And the reason it's linear is clear from this graph. I'm fitting a straight line to these 2 points, and then I'm finding where I think it is. So if you've understood this first example, which is a bit removed from statistics, I suppose, you've understood the main premise of linear interpolation. So far, we have looked at we've looked at stem and leaf diagrams and the quantities we can calculate from that. But then I talked about the fact that we have not yet covered how to estimate the median from a group frequency table. We can work out what group it's going to be in, but not actually estimate the value. What I've then done is introduce the idea of linear interpolation, how if we have some values and we know how far we're going from them, the fraction, then we can make an estimate for what the value would be at another point. So we're going to bring it all together now, or in a second, and show how we can actually make an estimate for things like the median in a group frequency table. First of all, I just want to say that this was a very simple model because it was only one-dimensional. I couldn't find the temperature at this red cross up here, for example. It doesn't take into account many things. It's the first kind of attempt at linear interpolation. This is a map of South Africa in 2009 that I just found, and here we've got lots of different places measuring the temperature, and then they've used interpolation, presumably linear interpolation, to try and estimate the temperatures in around and they've made a heat map to illustrate that. So that you'd have to have a key, but you could then maybe estimate what it would be like here or here and so on. So all I'm trying to show from this is that we're just looking at one-dimensional interpolation, and that's absolutely fine. That's all we need to do in our case. But you can take it further, and actually, this is probably what is being used when you work out if you have a boiler, for example, and it's measuring the temperature outside your house. It's not actually measuring the temperature. It's actually tuning in to different weather stations in the local area that then interpolates to give you a good reading. Okay, let's have a little go then at interpolating from a grouped frequency table. So this one's a little bit controversial, I think, but A, how would you estimate the first 5 values in this frequency table? Well, that's a difficult one. Do you start at 0 or do you end at 10? Do you try and incorporate them all? And actually, this is what tends to happen, and you might disagree. I can take that on board, but we tend to say that actually, if we're going up 2 every time. So 2, 4, 6, 8, 10, and the final value actually does lie on the 10, because that takes us nicely into the next set of values where you wouldn't start on 10, you would start 1/8 into the group. So if you're not happy with that, well, you just got to roll with it, because that's basically what we assume when we have grouped frequency tables. So if we're estimating the 6th value, we're now basically going to be incorporating what we had on the map. It's going to be that we are 10 in, because we've got this height of 10. But now, how much am I adding? Well, the width of my next group, because that is where the 6th value is going to lie, the width of that group is also 10. But I'm not going 10 along. This is just like when we added the temperature of 2 degrees. I'm actually going along 1/8 of the full amount. So this is our first kind of interpolation within a group frequency table. Instead of the starting temperature being 27, we got this height. This starting kind of height is 10, but then we incorporate the fact that we're going a fraction of the way through, in this case 1/8 of the way through, and we times that by the group width. So I suppose this is your start, this is your fraction, and this is your group width. And that will be the case for all of our linear interpolation examples once we've worked out the fraction that we're going in. And so that will be 1/8 of 10 is 1.25, so we're going to get 11.25 here. Okay, now that I've said that, can you have a go at estimating the 14th value? Well, the 14th value, okay, if we look at the cumulative frequency, we've got 5, 13. It's going to be the first value that's in this next group. So it's going to be 20, and this time the width is, well, it's still 10, but I'm going to be going 1/19 of the way through. So I can figure that out. 10 divided by 19 plus 20, I can estimate it as 20.5, and whatever it is, meters and so on. Okay, I'm going to give you one more little bonus question before we look at the median, actually. So let's call this C with a little smiley. How about, I don't know, let's look at the 10th value. How could you estimate the 10th value? Okay, well in this case we identify it's going to be in this group, the 10 to 20 group. So my starting value is 10. Now, how far am I going through? I'm actually going 5 into it. So, but the total's 8, so I'm going 5/8 into my data. And then my width is still 10, so I can figure that out. 5/8 of 10 plus 10 is 16.25. So I'm hoping that you're happy with this, that if we have a value that we're trying to find, we can now use this linear interpolation to work it out. Work out what group it's in. You've got your starting value, work out the fraction you're going through it, times it by the group width. Well, a lot of steps, but this is repeated throughout linear interpolation. Okay, finally, calculate the median of this data. All right, well, we need to count how many we've got. We've got 13, 17, 26, 35. Blimey, if I calculate that right, 36. How did I get that? Okay, so we're actually looking, so the median position is going to equal 36 over 2. Now, I need to say something about this. Previously, I made a mistake. I said that the median position of this lot of data was 40 plus 1, but that's wrong because it's a bit confusing. But when you have listed data, you do the plus 1 divided by 2. But when you have grouped frequency data, you don't worry about adding the 1. It's a bit like when you do cumulative frequency, you just tend to, if you're finding the median there, you just divide it by 2. It's the same kind of idea. It's not going to take into, like, it's not going to matter that much, and actually it just makes life a bit easier. I think that's maybe one reason for it. Remember, this is an estimate. Okay, so now that I've made that apology, back to this, the median position is going to be the 18th value. And once we've got that, we're back to where we were. Okay, so the 18th value is going to be in here, but it's going to be the 5th value, okay, because I'm up to 13, so the 5th value in this final group. So it's going to be 20 plus 5 over 19, because that's the fraction I'm going up, times that by 10. It gets pretty fun the more you do. And I get 22.6. Very powerful. We can now find an estimate for things like the median. Let me just check if I agree with one. Why do I not agree with the one I did earlier? Okay, just going to check this. 5 plus 8 plus 19 plus 4, 36. I wonder... I think my current answer is correct. Bear with me 1 second. Okay, I can see what I've done here. Right, I got that old answer when I must have made this mistake in the past as well when I added 1 to the median. But maybe there's a convention and sometimes you can. You know what? I'm not. No, I am sure. You don't. I am sure. Forget that. You don't divide, but you don't add the 1. Okay, so that one's wrong. 22.6 is correct. It's all good. Make sure you use that idea. You just divide it by 2 when it's grouped frequency. Okay, so I'd like you to now, because we talked about this previously, finding out which group the median is in, can you now find an estimate for the median? Right, so we've got that the median position is 20, so I'm going to write the cumulative frequency down 2, 7, 14. Okay, yes, we see that we're in this group, but furthermore, we are 6 into the group. So the starting value is 300. We are going 6 over 12 of the way through. The width is 100. And actually, in this particular case, that's just going to give me a very nice answer, which is the midpoint. It's going to be 350. So to summarize, if you're working out the median in a group frequency table, you look for the n over 2 value, however you say that, and then that helps you work out the group the median's in. You write down the boundaries. You're particularly interested in the lower bound of this group. You work out the fraction of the way along that you're going, just like we've been doing, and then you can work out the median as the lower class boundary plus a over b times the class width. That's what we've been implementing. Okay, let's have a go at a few more questions. So pause the video and see if you can find the median of the estimate, I should say, the median of this grouped frequency table. Okay, I'm going to go through this. So we're going to add up the frequencies. 5 plus 9 plus 8 plus 6 plus 3. That gives us 31. In this case, n is equal to 31, and n over 2 is going to be 15.5. Right, so let's work out the cumulative frequency. We've got 5 and 14. Actually, it's going to be the 1.5 value in this group. So I've got my lower class boundary, which is 30, and then the fraction that I'm going into the group is 1.5 over 8. I'm going to times that by the group width, which is 15. Just going to say that once again, just going to remind you, like we've got the lower class boundary, we've got the fact that we're going 1.5 into the data and there's 8 values in total, so that gives us the fraction, and then I've just done 45 minus 30 to give me the width. Okay, chuck this in a calculator, and I get 32.8125. Remember, this is an estimate, so I think we should round it to 32.8. There we go, there's the median. Okay, how about this one? Well, this one's a little bit trickier because it's one of those grouped frequency tables where it's just, you've just got a hyphen between the values and you've got to figure out what the actual group width is. Well, to start with, let's focus on n. So n is equal to 30. They've actually calculated that for us. So n over 2 is going to be 15. I'm going to count up my cumulative frequency. 2, 5, 8, 13. I'm actually going to be looking for the second value in this group here. Okay, now we've got class marks here, and this is a little bit confusing because you're not ever going to get a decimal mark, really. Like, you're going to expect to get a full number of marks. However, we are still going to use the idea of lower bounds to help us with this. So actually the group is going to become 30.5 less than or equal to x less than 31. It's normally a bit clearer, and this one stumped me to start with. Oh, not 31, 31.5. Okay, we do incorporate that into it. And so our width, hold on, what am I talking about? Not 31.5, 35.5, sorry. Our width is still going to be 5, essentially, not just 4. That's the main thing to take out of this question. So then it's the same as before. It's going to be 30.5, that's our lower bound, plus the fraction that we're going through, 2 over 6, times the width, which in this case is 5. And I get 32.16 recurring, which I'd then round to 32.2. Okay, hopefully you're happy with that. Maybe you're just thinking, oh, I'm not quite sure about that bit there. I'm just trying to be convincing the fact that you can't just have the widths as 4, 4, 4, because that won't then, you can see it doesn't add up. If you're going from 31 to 40, how can the width be 4? We do need to have this set up. Okay, how about this one? Very similar question. This is a bit clearer, to be fair, because it says it's been recorded to the nearest minute. So I'm still a bit like, really? Are we really going with that? But that's convention for how we deal with it. But it's a bit clearer here because it says that it's recorded to the nearest minute. Can you use linear interpolation to estimate the median time? All right, so let's add up the frequencies. Hopefully getting into this habit now, just before we worry about the group. Add up the frequencies. Again, it's 30. N is equal to 30. N over 2 is equal to 15. Let's find essentially the cumulative frequency. So 5, 12. Okay, it's going to be in this group here. I can see, and it's going to be the third value. Right, this time it's definitely clearer that it's going to be the group 8.5 less than or equal to x less than 14.5. So we're going to take our lower bound, we're going to find the fraction that we're going through, we're going to times that by the width, which is 6, and it's all good. We're nearly there. And I get 10.75. Which you might round again to 10.8 because it's an estimate. We're assuming that this data increases at this steady straight line. Okay, we are nearly there. We've spent a fair bit of this lesson talking about linear interpolation to find the median, and also, how could you estimate particular values inside a grouped frequency table. Well, I did talk right at the start of the lesson about also finding the interquartile range of grouped frequency and estimating that using linear interpolation. It's exactly the same idea. So let's not stop. Let's just do this final thing. And also we can find these things called percentiles. So the lower quartile is actually the 25th percentile. It's 25% of the way through the data. And the upper quartile is 3/4 or 75% of the way through the data. But we don't have to just stop at that. We could also find the 70th percentile, which is 70% of the way through the data. So now I've said that, can you have a think about how you would possibly work those out? If you're not sure, carry on watching, but using the tools that I've already taught you, can you figure these things out? Okay, I'm going to call this part A and this part B. They've actually added up the frequencies for us. It's going to be 60. Now this is going to work in exactly the same kind of way. So for A, we need to actually do 0.7 times 60, which is going to be 42. And the 70th percentile is going to be the 42nd bit of data in the table. And once we've done that, we're back to where we were before. So let's work out the cumulative frequency. Okay, I've got 37 here, so I can see it's going to be the 5th value in this group. So for the 70th percentile, it's going to equal the lower bound 12 plus the fraction that I'm going up, same sort of stuff as before, 5/14, times it by the width, which is in this case 4. And hey presto, we've got the 70th percentile. I'm just going to write it straight down as 3 significant figures, 13.4. Why might you want to do this? That tells you that 70% of the, whatever it is, the leaves have a width of less than 13.4. It's a bit like, when you draw a cumulative frequency graph, which you could do for this. If you read off the graph using a straight line, this is what you'd get. But actually, we're doing it more accurately now because we're using a more rigorous approach. You could work out the range at which 90% of the data is held. The interquartile range goes for 50% of the data is within this value, the quarter point and the 3/4 point, but there's nothing stopping you finding other ranges. We can extend the idea of interquartile range, and the 70th percentile is looking at that, because you might be interested in the 30th percentile as well, and then find the range between those. But as a quantity, it's still useful. Okay, finally, interquartile range. So for the lower quartile position, I think I'll do this in a different color just to make it clear. Okay, it's going to be 0.25 of the way through the data, or 15. And then if we're using our cumulative frequency, we can see it's going to be the 7th value in this second group. So it's going to be 7 plus the fraction 7 over 12 times the width, which in this case is 3. Which is 8.75 or 8.8 to 3 significant figures. I'm not writing that down, but yes, I've rounded it. Upper quartile, very similar position is going to be 0.75. Look, we can already see what it's going to be. It's going to be 45. So the upper quartile, okay, oh, again, sorry, let me do this in a different color. So, oh, sorry. Okay, so I'm looking for the 45th value. So actually, it's going to be in this group here, because I've got 37, but it's going to be the 8th value in this group. So it's going to be 12. Of course, it's going to be just slightly after the 70th percentile, because it's the 75th percentile. Hopefully that makes sense. So it's going to be 12 plus 8 over 14 times 4. Which is 14.285. Round that to 3 significant figures. We're really close. Finally, interquartile range. Check it out. We can now estimate the interquartile range from a group frequency table. How amazing is that? Right, we're going to take our non-rounded values, so 14.285 dot 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 minus 8.75, which gives 5.53, which I'd round to 5. 5.535. I don't feel like there's enough accuracy to put that extra 3 in, so I'm just going to round it to 2 significant figures here. I suppose I'm rounding it to 1 decimal place throughout, actually. I did say significant figures for 8.8, 3 significant figures, but it wasn't. Brilliant. So we've estimated that 50% of the data, the middle 50%, has a range of 5.5, which is pretty good going. Okay, thank you for watching. Hopefully this all makes sense and you're now confident about linear interpolation in grouped frequency tables.